Hi everyone, we're still in chapter 1 as a review of grade 7. In this session, we will revise some information about area, surface area, and volume. So first of all, we should know that the area is measured in square units. If the length unit that we are using is centimeters, so we'll obtain the area in centimeter square or the square of centimeter. And if it's millimeters, so we'll obtain the area in millimeter squared. Okay, and we can find the area of regular forms. But for example, if we are having a shape, for example, or in drawn on a net diagram, so normally we can easily find its area by counting the number of square units. For example, in the first example, we can count the small squared purple to obtain 30. We have 33 square units. So normally we have 33 square units. We have this one, and we know this square is 1 by 1 because we know the area of a square equal to side by side. 1 by 1 equal to 1. So each small square has an area equal to 1. So we add the 1 plus 1 plus 1 33 times to obtain the area of this purple shape equal to 33 square units. Okay, we should know and keep in mind the area of some particular 2D shapes and quadrilaterals as a square. The area of a square equal to side by side. The area of rectangle length by breadth. The area of triangle is the half of the base by height. And this height should be perpendicular to this base. Okay, the area of parallelogram equal to the base by height. Okay, and the used base we need to take into consideration the height perpendicular to this base. Let's move to some application. We have a square. Why it is square? Because all the sides has the same lengths, and we have at least one 90 degree as an angle. So normally the square with the length of each side equal to 7 meters, so 7 by 7 side equal to 49. And the unit of length is meters, so the unit of the area is meter squared. We have a rectangle length by breadth. Length by breadth equal to 33 millimeters squared. This is a triangle, so the half of the height base, so normally equal to 49 centimeters squared. Be aware about be very intelligent when putting your square units. Here, for example, we have a more complex form. It is not rectangle, it is a square, and neither a triangle. But if we can cut it here, we will obtain like a small square and a rectangle. So if we can find the area of the square and we add it to the area of this rectangle, we will obtain the area of the whole shape. So it is 4 by 4, the area of the square, and the area of rectangle equal to 4 by 8. And so it is very easy to obtain 48 centimeters square. Why this distance equal to 4? We know that this one equal to 4 because we have the same mark, like this one, so 4. And because we have a square, so all sides are equal, so normally it is 4, so the length is 4 plus 4 equal to 8. And moving to the following one, we have different cases. We have, for example, here we can take this one as 2 triangles. So 1/2 height by base plus 1/2 height by base. Okay, here we have a triangle and rectangle. We add the area of both to obtain the area that we need to know. In the following exercises, we have an empty region inside, but the empty region in white is a very particular shape in 2D. particular shape as a rectangle. So as a whole, we have, in general, we have a parallelogram. So it is the area of a parallelogram, height by base. Okay, 6 by 10. But we need to subtract the area, the empty area, which is an area of rectangle with the length equal to 5, breadth equal to 3. So the area of the rectangle equal to 5 by 3. So we subtract 5 by 3 to obtain 45 meter square. And the same idea is here. We have in general, we have a triangle 1/2 height by base, and we subtract the area of this small square 10 by 10. Easy. What about surface area? For 3D shapes, we don't talk about area. We talk about surface area because we have different sides. We have right side, left side, we have a top, we have a bottom, we have a front, we have a back side. So normally we need to know the area of each side alone, and we add all this area to obtain the surface area. So we talk about surface area of 3D shapes, and we talk about area of 3D shape. Okay, so how? We identify all faces, calculate the area of each face, and then we add the areas individually to obtain the whole surface area of the whole 3D shape. It is always recommended to take the bottom face as reference to draw the bases next to. And what about volume of any 3D solid? The volume, it is the area of the base by the height. Differently said, how to obtain the area of the base, or area of the base is the area of the uniform cross-section. We will explain it later. In the exercise 5, they ask us to calculate the surface area of each solid. Normally, we have a prism. We have a rectangular prism, and here we have a triangular prism. We have a rectangular prism, so we have a front, we have a back similar to each other. We have a right, we have a left face similar to each other. We have a top and bottom each other, and each face is a rectangle, so length by breadth. So front and back, we can say 2 times the front area. Front area, it is a rectangle with the length equal to 9.5 and breadth equal to 3.1. So we multiply it by 2 to obtain the area of the front and the back. The left and the right are similar, are congruent. So normally the left is also a rectangle with breadth equal to 6.8 and the height equal to 9.5. So 6.8 by 9.5, and we multiply it by 2 to obtain the area of the both faces. And similarly to the bottom and top to obtain finally the surface area equal to 230.26 centimeters square, because we are using the centimeter as unit of length. How about volume? Normally they in this exercise they give us the area of the base. The area of the base by the height. The area of the base is in centimeters squared. So normally the volume in centimeter cubed, because we multiply centimeter squared by centimeter, we'll obtain centimeter cubed. Like A2 by A1. Normally it is we add the exponent. We have 2, we have a 1 to obtain A3. So centimeter squared by centimeter will obtain centimeter cubed. And similarly, we have the area of the base by the height. Okay. And how to calculate the volume of each solid if we don't have the area of the base ready. We imagine a little bit a uniform cross section. If we for example, we decide to slice or to have a slice horizontally in this one, we should know, or we should ensure that all sections along this vertically along this prism should be uniform, to take it as uniform cross section as a base. So normally yes. So normally the base can be taken as or the uniform cross section can be taken as the rectangle in the base 6.8 by 3. So normally we take it 6.8 by 3 as the area of the base, and we multiply it by the height to obtain the volume. Easy. And the cross section here can be taken if we take a cross section horizontally. So normally if we imagine a little bit, so going along vertically, we can't ensure that we have the same across with the same slices, horizontal slices. Okay, so normally if we take a cross section in this way, okay, in this way, okay, and in this way, to obtain, yes, so yes, we obtain a uniform cross section. So we take the base of this one and we multiply it by the height 5. Easy. So you should know also, if we have a composite solid, what we mean by composite solid: a combination of two or more of standard geometric solids. Okay, how to calculate the volume of a composite solid? We break the composite solid into simpler solids. We find the volume of each one separately, and we add or subtract the resultant volume. For example, here we have this one. It is not a composite solid. Uniform cross section is this one normally. So we find the area of this base, okay, and we multiply it by the height to obtain our volume in centimeter cube. But in this one, yes, it is a composite solid because we have a cube we have a cube in the bottom, and at the top we have a triangular prism. So normally the cube easy. We take the bottom as base area of the base, and we multiply it by the height to obtain it is not prism. Normally it is not a cube, it is like a rectangular prism, because the cube has all sides lengths of its sides equal, but here we have a 9.4 and we have a higher 5.8, so it is a rectangular prism. Plus we take the base, or the uniform cross section is this one. So normally there's a height by base by 1/2. By the height, its height equal to 5.8. This is the height referring to this triangular prism. Okay, and also it is easy to find the volume of this one, this composite solid, because if we take we cut it here, we will obtain a rectangular prism, small one top, and we have a big one, okay, like matched box in the bottom. Okay, so normally it is easy to calculate the volume of a small rectangular prism, and we add it to the volume of the big rectangular prism. These are the main idea of this section. Thank you for listening, and bye-bye.